Come to physics, maths, and science class. Today we want to talk about hydraulic press. How to calculate the force needed to raise a car. We have done pressure and we learned that pressure is the force per unit area. And what are some of the applications of pressure in our daily life? And one practical example is the hydraulic press. And this is how hydraulic press is used. So we can use this diagram to represent how hydraulic press works. When a car breaks down and we want to lift the car to a fitting shop or a magazine for it to be serviced, this is how the hydraulic press works. Within the hydraulic press, we have a cylinder here with pistons, and the force which is applied within this cylinder will cause the fluid to move into this tube, which will generate a high force, and that force will enable the car within this master cylinder with the presence of the pistons, which will cause the car to be raised. So we are assuming that there is a force here with small f, and this force is pushing or exerting energy on the master cylinder, which will cause the fluid in the pistons to move to generate a high force. So within the master cylinder, there are some distances which create an area within the master cylinder, since there is a presence of pistons. So we have a small a represents the area of distances within the master cylinder in the first part. Now we also represent the effort which is applied, which is the force, by small f. And we know that force is also also calculated in mass multiplied by what? The gravity. When we come to the main master cylinder, where the high force is applied, you could see that within this master cylinder, we also have some pistons. And these pistons will have some distances. And the distance creates an area, since pressure depends on surface area. So we represent A, capital A, for the main master cylinder. Then the capital F represent the force which applied. The force which applied for the car or for the object to be raised. And also know that force is also calculated by mass and gravity or mass and acceleration. So we are representing capital M and G for the big F. Now, from our previous studies, since we want to calculate or prove on how the greatest force needed to raise a car using the hydraulic press, we know pressure, which is P, is equal to force over area. We can name this equation 1. Now, within this first cylinder here, where the pistons are found, we can also calculate the pressure that was exerted when the force applied. So we can first calculate the pressure within this area. So pressure can be calculated from the first master cylinder to the small f, which will represent the force applied F, by the area there, which is what? A. Now we can also be calculated from assuming you don't have force and you have the mass. You can also calculate the force by using mass mg against A. So in case in hydraulic press we want to calculate the force, the pressure, the area within the first master cylinder, then we can apply these formulas to calculate. That pressure is equal to force, which is the small force, that was the first force applied, against the area. And so F against A should be equal to the mass and gravity against A. So this is equation 2. Now, let's come to the second or the main master cylinder, where high force was applied. Because when this move into the cylinder, it will generate a high force within the pistons, which will cause the what? The object or the car to go to be raised. Now from here, we also notice that within the pistons there are some distance which is an area. And this area here represented by A, capital A, and the force exerted by what? F. So by calculating the pressure too will be also force against the capital A. That one too is also equal to M, which is force is also mg. Capital Mg against what? Capital A. Equation 3. We can equate equation 2 and 3 together. So let's equate it. We have F against A is equal to the small mg against what? Small a. And that can be equal to capital F against capital A. And that will be equal to capital Mg against what? Capital A. From here, we can have F because we can group like terms. F and A are like terms, so we can group them together. So from here, we can have small f over A, which is equal to capital F over capital A. So this is equation 4. And we can use this equation to calculate the force that was exerted within the hydraulic press when it was what? Able to raise a car or an object. We can also calculate the force or the high force generated when the car was able to raise by using the equation 4. Now, we can also see some like terms again. We have mg against A. I also have mg against A. So let's see. Small mg against A can be also equal to capital Mg against A. And this A here is capital. Now, we can see that there are some common terms here, G and G. But this one is small m, capital M. So from this one to, we can divide both sides by what? G here by G. And G will go and G will go away. So from here, we can have small m against A, which is equal to capital M against what? Capital A. So we can also use this equation to solve. So in case you are to calculate the mass of an object that was raised using the hydraulic press, you can use this formula to calculate. In case you are to calculate the force that was exerted for a car to be raised using the hydraulic press, we can also use this equation to calculate. So this is how hydraulic press work. Now we will end here. In our next episode, we are going to use these formulas to calculate and solve some simple questions. Thank you for watching and God bless you. Bye bye.